Alright, so today we're starting graphs of sine and cosine. We're going to recognize and graph periodic and trigonometric functions. All of the trig functions that we've talked about, the sine, the cosine, the tangent, are periodic functions. And that means that they repeat, okay? They repeat exactly in a pattern, okay, which is called an interval or a cycle. And the length of one cycle is called the period. And that changes depending on what your equation is. So there's an example of what a periodic function looks like and a non-periodic function looks like below. Your cycle can begin at any point on the graph. When we're looking at like the sine and the cosine, we'll talk about their relationship to 0. Okay, but an easy way to measure what the period is you go to the same point. So like this, like here to here, that would be the same place. Okay, it's at the top of the graph. These are at the bottom. And then this will be something that's non-periodic, that doesn't repeat. And then on page 754, they give you a few more examples. So from the top of the graph to the top of the graph, that would be a period. And if you look here, this is at -1, this is at 1. So you just count how many units. So this is 1, 2 units over, so the period is going to be 2. Now be careful because sometimes they look like they repeat, but they're really just symmetric. So this is going 1 up and then another one up, but then see how this is going down? So it's symmetric, but it's not periodic because it's not an exact repeat of the pattern. Okay? Alright, so let's look at the examples that you guys have on here. Okay, so for example 1, determine whether each function is periodic. And then if it is, we're going to give the period. Okay, so what do we think? Does this one repeat the same way over and over again?
Yes.
Yes. So what we can do, a good strategy is the top of one to the top of another, and then we want to find what those units are. Okay, so if you look at this, see how this is a little bit to the left of pi? This is a little bit to the right of 0. Okay, so here it is periodic. And then the period is pi. Okay, and normally we say like capital P, so this would be equals pi. You could also measure like from here to here. That would be fine. Or from 0 to 0. Okay, what about B? Does that repeat exactly?
No.
No, because here the steps are going down and here the steps are going up. So this is not periodic. What about C?
No.
No, because if it was, you would be able to see the exact same place. See how this that never goes back to this level again? So it's not periodic. So you should be able to draw a line to the same place if it is periodic. Okay, what about D? Yes. So you could draw this from like the arrow to the arrow here. You can't see this part, but very soon it would go to the 0 again. But it's going to be a lot easier to do from the arrow to the arrow. So how many units are between from arrow to arrow? You count them. 3. So this is periodic, and the period would be 3. Okay, so the period can be in radians or it can be a number. Okay? Alright. I know that yours looks a little different than mine. Yours doesn't have this space in there, so we're going to put that somewhere else on yours. What we're going to talk about next are the connections to the unit circle. So the trig functions that you studied, this should say in chapter 10, there's no 13 in this book, are periodic. So you can graph this function, f of x equals the sine of x, using using the y-coordinates. Do you guys remember that the sine function on the unit circle, the sine corresponds to the y-coordinates. What does the cosine correspond to? Yes. So when we talk about the function cosine of x, that is going to be related to the x coordinates. Okay? They are no longer in a point. Your x value, or your independent value, okay, this independent variable represents the angle of theta in standard form. Okay? So we're going to be using the theta values in radians to help us think about this. Okay? So you have this pi over 2. What we're going to do, and 0, what we're going to do is we're going to label the points on this unit circle. So at 0, do you guys remember what the point is? 1, 0. Here you have 0, 1. At pi you have negative 1, 0. At 3 pi over 2 you have 0, negative 1. And then you're back here. Now remember, after you go around once, you're also at 2 pi. Okay, so 0 and 2 pi are going to have the same values. Okay? Alright, I'm going to put my table here. You guys are going to sneak your table in over here, okay? Because this is where yours is, right? Okay, so we put an x and then the sign of x just on the side. Okay, so the x, and then I want you to put the sign of x. Okay, so remember, the sign of x is what coordinate on the unit circle? The y. Ooh, that's a lot of ink. Okay, so the y coordinate there. Okay, and then what we're going to do is we're going to plug in the values we just talked about. We're going to plug in 0. We're going to plug in pi over 2. We're going to plug in pi, 3 pi over 2, and 2 pi. Alright, so when you plug in 0, okay, if you were to plug this in for x, you'd have the sign of 0. The sign of 0 is the y-coordinate at 0. What's the y-coordinate at 0? This is 0. What's the y-coordinate? 0. Okay, now we're going to pi over 2. What's the y-coordinate at pi over 2? 1. What's the y-coordinate at pi? 0. Y-coordinate at 3 pi over 2? Negative 1. At 2 pi? 0. Now I want you to look at how these correspond to the sine function. So this is one cycle of the sine function. It starts at 0, and notice that it curves. Okay, this is the shape for one cycle of sine. Okay, so it starts at 0. It's not labeled here, but this is your 2 pi. And there are these 5 points is what we focus on. So you have 0, 0. At pi over 2, you're at 1. At pi, you're at 0. At 3 pi over 2, you're at negative 1. Okay, so these are values that we're going to be talking about a lot today. Okay, we're also going to label it on the other side, but I want you to see that these come from the unit circle. Now, you also have this table here, okay? At pi over 3, the y-coordinate is root 3 over 2. Okay, that is great, and that is what you see here with your dashes. Okay, so this is pi over 3. At pi over 3, it's root 3 over 2. That's the decimal. But we're not going to want to be graphing the decimals. We're going to want to focus on these points, okay? All right, so let's look at H2. Oh, my bad. Yes, we are filling in that. Yeah, that amplitude. Okay, so we just right here that the amplitude of sine and cosine functions is half the difference between the minimum and the maximum values. The amplitude of sine and cosine is half the difference between the minimum and maximum values of the function. So, for example, okay, what is the maximum of sine? So what's the highest value? No, what's the highest value it gets to? 1. What's the lowest value? The min is -1. So if you were to find the difference between them, you would do 1 minus -1, which is going to be, what's 1 minus -1? No. 1 minus -1 is 2, right? Because minus a negative means plus. So it says it's half of the difference. So we just have to multiply this by a half. 2 times 1/2 is what? 1. So this is the amplitude. Okay, there is going to be a shortcut to finding that, but if you just had your graph, you have the graph and not the equation, that's what you would have to do. So subtract the lowest and the highest, that's going to be your amplitude. Okay, now notice it says the amplitude is always what? Positive. The amplitude is always positive. Okay, so, one thing I want you to notice on your characteristics chart is this is a full cycle for the sine, this is a full cycle for the cosine. So you have the sine of x and you have the cosine of x. Okay, notice that 1 period for each is 2 pi. That means you go from 1 full cycle and then you start to repeat. Okay, the amplitude for each of these is 1. Now, for each graph, we're going to focus on 5 key values. Okay, the 5 key values are here in each of these, in 1 period of each of these. Okay, so we're gonna draw this, okay, with the special points in, okay? And then I want you to make just like the axes here, and then we're gonna talk about this. We're gonna graph these in a certain way where you are going to use a pattern. So because they're periodic and they repeat, they use these special patterns. So notice where the sine starts. The sine starts at 0, 0. So start there, okay? And then we're also going to make a little chart. Okay, so 0, 0. This is where you start. Okay, now, where you end is going to be at the end of the period. Okay, so if you start at 0, you're going to end at 2 pi. Okay, so will you put that at the very bottom here? So you start and you end at the same place. And this is the end of 1 period. So this is why you end at 2 pi, because that is 1 period. Start at 0, end at 2 pi. Now, what happens halfway in between is it goes to 0 again. So halfway in between these, halfway between 0 and 2 pi is 1 pi. Okay, so this is what I just call the halfway point. So it's the halfway of your period here. And then look what happens halfway in between those. So halfway in between those, you go to your value of 1. That is your max value. So at pi over 2, you hit 1, which is your max. Halfway in between pi and 2 pi is 3 pi over 2. That is -1. That is the lowest point that you go to. So that is your minimum value. And then you keep repeating that cycle. Now when you connect these, you do have to connect them with a curve. Okay, and this does continue here, and this will continue this way, but this is one cycle. Okay, this is one cycle. The cosine for one cycle is going to be a little bit different. So I just want you to take a look at the chart. And then I want you to look and see where the cosine starts. Okay, so look at your chart, look and see where your cosine starts. And we're just going to make our little grid again. Okay, so at 0, what is the cosine? Yep, at 0, the cosine is 1. Okay, doesn't sound like we were too confident, so let's think about this according to the unit circle. So if I were to do the cosine of 0, right, again, we're going to think of this. Here is 0, right? At 0, what's my point? 1, 0. So at 0, what should the cosine be? 1. Okay? So this is where we start. Okay? Now, if the period is 2 pi, where am I going to end? I'm going to end at 1. What's going to be my x value? No, 2 pi. Because the period's 2 pi, right? Okay? So in this case, you start at your max value and you end at your max value. So for cosine, you start at the max, you end at the max. What happens exactly halfway in between your two max values? You go to the minimum, and that is at pi. Yep, at pi you hit -1, which is your minimum. Now, what happens halfway in between the max and the min? What do you hit? 0. So at pi over 2 you're at 0, and at 3 pi over 2 you're at 0. So when you graph according to the pattern, okay, you're going to start at 0, 1, because this is where you are at your max. This is 0. Okay, at 2 pi, you're also at your max. Halfway in between, at pi, you hit your minimum. So let's label the -1 as the minimum. And then halfway in between there, at pi over 2 and 3 pi over 2, that's where you hit your 0 values. And then again, this is a curve. And then it will start to go down here, and it will start to go down here. Okay, so that's going to be a very important pattern that we're going to emphasize today. So you can use these parent functions to graph transformations. So if you have this form of y equals a times b, y equals a sine of bx, and y equals a cosine of bx, just remember that when you have that value of a, that is a vertical stretch. If the absolute value is greater than 1 and it's a compression, if A is between 0 and 1, the absolute value. And the reason why we use the absolute value is because if it's a negative, there would be a reflection. Now, it's important to note that the A value changes the amplitude. Okay, so A is going to change the amplitude. Okay, if A is less than 0, so a negative number, okay, then the graph is reflected across the x-axis. Okay, and the value of B is going to indicate a horizontal structure compression. Remember, we did a lot of work with that in semester 1. Okay, so horizontal structure compression. And if it is a horizontal structure compression, that value of B, that changes the period. Okay, so a vertical stretch affects the amplitude. A horizontal stretch is going to affect the period. Okay, and remember, the period is just how many cycles there are. Alright, so for these graphs where A is not 0 and X is in radians, okay, the amplitude is the absolute value of A. Okay, so this is where A is. A is multiplied in front of the sine or the cosine. Okay, the period is 2 pi over B, and B is in front of the variable of X. Okay, it is inside the trig function. Again, because the amplitude, you have this absolute value, that's just another reminder that the amplitude is what? It's always what? Absolute value does what? Makes it positive. Amplitude is always positive. Okay, and then when we're writing out the period equation, it's usually just 2 pi over B. Okay, just make sure that you don't put the negative with it. And that's what we're going to use to help us in example 2. Okay, so we are using the parent functions as a guide to graph each function, and we have to identify the amplitude and the period. Okay, so when it says to find the amplitude, remember the amplitude is this value here in front of the function. So the amplitude is 1/2. Okay, to find the period, you have to do 2 pi over B. Okay, so to find the period for this, we do 2 pi over 1/2. Remember, when you are dividing by a fraction, it's the same thing as doing what? Multiplying by the reciprocal. So the reciprocal of 1 over 2 is 2 over 1 or 2. 2 pi times 2 is 4 pi. So this is going to be your period. It's 4 pi. That means, okay, that it repeats itself every 4 pi. Okay? So 1 cycle every 4 pi. Now, when it says what is happening to that graph of sine, we're thinking of the vertical and the horizontal transformations. So vertically, what is happening? I guess I should just say vertical. Is it a stretch, compression? What's happening? No. So it's on the outside, it's 1/2. It's a fraction, right? Yeah, so vertically compressed by 1/2. Okay, what that means is vertically it is being compacted. Okay, when you have this amplitude of 1/2, that's going to change the maximum value. We're going to talk about that. So vertically compressed by 1/2, what's happening horizontally? Yeah, why is it stretched? It's the reciprocal, right? Do you guys remember that from the first chapter?
Yes.
And the second chapter?
Going back.
And the third chapter? You did it in the first 4 chapters. So this is horizontally stretched by a factor of what? 2. Okay, so we do the reciprocal. Now, remember, horizontally it affects the period. That's why this has gotten larger, because it's being stretched. Now, we said that the are you alright?
Yeah.
If you were watching the video, a student just fell over. Not be alarmed. Everything is okay. Is your ego okay, or do you need a phone?
What?
Is your ego okay? Do you need a phone?
Yeah, I'm ready for
Okay. I told you not to sit like that. Well, we're all awake now. Okay, so the new max value is 1/2. Okay, this corresponds to the vertical compression. Okay, so your new max value is 1/2. Your new min value is -1/2. Okay, and that is tied directly to your amplitude, which corresponds to the vertical compression. Okay? Alright, now, I am going to show you how you can graph this in your calculator, so that as you're doing this, you can check, but 2 things. 1, you won't have your calculator on your quiz. 2, you won't need it because it's going to be pattern-based, because sometimes using a calculator is actually a little bit confusing when you have radians, but this is going to be a time where your mode will be in radians, okay? So we're always going to pick 5 points to put on our table. Like I said, I am going to be showing you this with, I'm going to be showing you this in terms of patterns. So we're going to go over this a few different ways. I'm just putting the equation back up there so we don't lose it from the other page, okay? If you don't have your graphing calculator, don't stress out. You can just follow along with me. But you do need to switch your mode to radians. Anytime you do these graphs, you'll be in radians. And then I put like what to put in here, but this blocked out the 0.5. It's 0.5 sine of 0.5x. Okay, so just put that in y1. So 0.5 sine of 0.5x. Like I said, you can also just use that with me. Now, when you are labeling your graph, when you are setting this up, okay, a really good scale to use is to take the period and divide by 4. Okay, so when it says label your graph, what I mean is we're going to label our scale. So the x-axis scale, a good way to determine that is to do the period over 4. So remember, our period for this was 4 pi, right? So if we do 4 pi over 4, that's going to be pi. Now you can choose to do every little line as pi or every other one. I'm going to do every other one just to give us some room here. And then when you label these, you are going to label them on the bottom. Okay, so this is 1 pi. What comes after 1 pi? 2 pi. What comes after 2 pi? 3 pi. And then 4 pi. And then we're also going to label the other side. So again, when you're labeling this, you are going to label at the bottom. So negative pi. And you can label just every other one, which is what we are doing. And you do have to span your entire grid. Okay, so like I said, I'm gonna show you how you can do this with your calculator, but I'm also going to show you how you can do it without it. this would be something where you could check with your calculator. If you had this, and then you went to your table, okay, this is how your table setups look right now, okay? See how you have 0, 1, 2, 3, 4, 5, 6, and then you have all these little decimals that are different here, okay? Like the 0.23, the 0.42, the 0.49. Once you are doing that, okay, that doesn't really make sense with what we set up. So you have to go to your table set, and instead, you can still start at 0, okay? Or you can start at -4 pi, which is what I put here, right? Because we have -4 pi there. So if you started at -4 pi, and then you went your table by pi, then it would give you what's happening every pi units, okay? So at -4 pi, this is 5e to the -14th. What does that round to? What does 5e to the -14th round to? Come on, chemistry, please.
5 times 10.
-14. What does that round to as a number?
I don't know.
Probably 0, right? Because we point 0, 0, 0, 0, there'll be 13 zeros in front, right? So that really does round to 0. That's what it's telling you. At -4 pi, you're 0. Okay? Alright, so this is, like at 4 pi, this rounds to 0. Okay, 0.5 is 1/2. This rounds to 0. 1/2, 0. This is 0. Okay, so you can use that to check, but it is just as simple, and in some cases more simple, to just use your pattern. So we can do that. Yes. I wasn't sure if it was that or something else, and I was gonna. Is it an emergency or could you wait until we do the pattern? You can choose. I'm just saying the pattern is important. Okay. Alright, so what we're going to do, because this is sine, we're going to use our same pattern. Okay, so where you start at 0. Okay, same pattern where you start at 0. So what I'm going to do is you can plug 0 into this. Okay, so I'm just going to put some of my work here for the table. So if I plugged in 0, I'd have 1/2 sine of, what's 1/2 times 0? What's 1/2 times 0? 0. So this is just 1/2 times the sine of 0. Well, all we have to do is think about the unit circle. Okay? The sine of 0 is 0. So 1/2 times 0 is 0. So guess what? That's where we are on our graph. Okay? Alright, so this is where we start. So we're going to start at 0. The ending value is always where the period is. So before it was 2 pi, right? But what's our new period? What's the period for this problem? 4 pi. So that's where we're going to end, okay? Okay, so we're going to end at the period. So guess what? Remember, it repeats itself. So if you start at 0, guess where you end? 0. Okay, so let's talk about this. There's a couple different things we can do. So we have 0, 0, we have this. Okay? Now, you could keep plugging these in. So you could plug in pi, and you could find this out. So this would be sine of 1/2 times pi. Do you guys know what 1/2 times pi is? Not 2 pi. Pi over 2, right? Pi over 2. What's the sign at pi over 2? That's at the top of the circle. Yep. So you have the 1/2 Yeah, 1/2 times 1 is 1/2. Okay, remember, we just talked about 1/2 is going to be the maximum, the new maximum, because that's your amplitude. Okay, so you could do that. Now you can decide. You can put 1/2 here. Sometimes I like to just go every other one. That is really personal preference, and you can decide. Okay. All right. So at pi, we're at 1/2, okay? We can also use our pattern. So remember what we just talked about. When it comes to sine, you start at 0, you end at 0. What happens halfway? You're at 0. So what's halfway between 0 and 4 pi? So at 2 pi, where am I? 0. So you could just put your point there. Okay, so this is the halfway. And then look, in between these two, I went to my max. So in between these two, where am I going to go? The min. So in between would be 3 pi, right? And I would go to my minimum. So at 3 pi, I would be at negative 1/2. You could verify that by plugging them in here, or you could verify it on your calculator. You have that. Okay, so when I say follow the pattern, this is what I mean. Okay, when you connect this, you guys might want to use your pencil first. Make sure you connect it with a curve. And then we're going to keep following the pattern here. Okay, so when I say follow the pattern, this is what I mean. We started at 0. We went 1, 2, we're up at the max. We go 1, 2, we're at 0. 1, 2, we're at the min. 1, 2, we're at 0. If I went 2 more, I'd be where? At the max. Okay, so if I'm going backwards, I just have to do, I'm at 0, right? So 1, 2, I'm at the min. 1, 2, I'm at 0. 1, 2, I'm at the max. 1, 2, I'm at 0. 1, 2, I'd be at the min. Okay? So it's going to repeat itself and keep doing that. And then you do want to put like your little arrows, and you do have to span your entire graph there, okay? It's okay that you have this big gap. All you need is 5 points, 1, 2, 3, 4, 5. These are going to be your 5 points that you're going to want to use. Okay? All right, now we're going to do one that's for cosine. So find the amplitude, find the period. Amplitude is always hanging outside here, okay? So your amplitude for this is 1/3, which means that that is your new what? 1/3 your new what? Max, yes. Okay, and the period is 2 pi over b. So this is going to be 2 pi over, what's my b? 2. Because it's in front of your x. What's 2 pi over 2? Pi. Okay, so this is your period, which means this is one cycle. So you're going to start at 0, you're going to end at pi. You're going to end at pi, okay? So this is what's happening to the graph. This time we're doing cosine. So cosine of x, okay? So vertically, what's happening? There's a vertical stretch or compression? Compression by what? 1/3. 1/3. Okay, horizontally, what's happening? Stretch or compression? Compression, because what's the factor?
Oh.
You have to do the reciprocal, right? So if you do the reciprocal, what's the reciprocal of 2? 1/2. Okay, horizontal is always inside there. Okay, and then we just talked about that amplitude is giving you your new max, okay, which is 1/3, and your new min, which is negative 1/3. Okay, so when you set up your scale, again, your scale for your x-axis, you're going to take the period and divide by 4. So if you have pi divided by 4, it's pi over 4. Okay? Now this is one where I usually, every single one I will do is pi over 4, because this would be 1 pi over 4. What's 2 pi over 4? Reduce 2? 2 over 4? Pi over 2? So this is 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4 reduces, 7 pi over 4, 8 pi over 4 reduces. So look, I have my key points on the unit circle. This is the most common scale you will see, where every other one is pi over 2. And those are the special places on the unit circle as well. Okay? So remember, we have to know what happens at pi over 4. So we have x, and then this is 1/3 cosine of 2x here. So when you are looking at your cosine at 0, okay, on the cosine starts at its max value. So if we're doing this correctly, I should get the max value for my cosine. So if I do 1/3 cosine of 2 times 0, 2 times 0 is just what? 0. The cosine at 0 is what? Not 0. It's 1. 1/3 times 1? 1/3. This is the max. Okay, so you start at the max value. Now your period is what? The period is pi. Okay, so this is where your period ends. So if you start at the max, guess what? You end at the max as well. Okay, now for the cosine, halfway in between the two maximums, where am I? The minimum. So what's halfway in between 0 and pi? Pi over 2. So that's where I should reach my minimum. Okay? So let's graph that part. Now it's 1/3, so I am going to label this as 1/3. This would be 2/3. 3/3 is 1. So this is negative 1/3. Negative 1/3. Okay, so at 0 I'm at 1/3. At pi I'm at 1/3. Halfway in between I'm at negative 1/3. Questions about those 3 points? The max, the max, the min. Start at the max, end at the max, halfway is the min. What happens halfway in between the max and the min? Where do you go? 0. So at pi over 4, you should be at 0. Okay, at 3 pi over 4, you should be at 0. This is your 1 cycle. That is 1 cycle. Okay, and you're welcome to put in like your pi over 4 is 0, your 3 pi over 4 is 0, or we can just keep going with the pattern, because look, I'm at 1/3, then 0, negative 1/3, 0, 1/3. So now I'm going to go to what? 0. Then I'm going to go to negative 1/3. Then I'm going to go 0. Then I'm going to go positive 1/3. then I'm going to be at 0 again. So just again, make sure you have this with a curve. Okay? And then we're going to keep going. So, like you could see here, oh yeah, at 3 pi over 2, I'm at negative 1/3. At 2 pi, I'm at 0. So yeah, you can absolutely do it like that. Or sorry, at 2 pi, I'm at 1/3. The next one, I'm at 0. Okay, so then let's finish the pattern. So this would be 0, negative 1/3, 0, positive 1/3, 0, negative, 0, positive, 0. So see how once you get the pattern, that's a lot easier than checking your calculator? Now the way to understand the pattern is to do your practice, and then I'm going to give you trig graph sheets for all of these, and I'm going to show you on the calendar like your due dates